Hi guys, in this video we're going to start talking about dilations. So if you want to pause the video and write down the definition, it's not a bad idea. But basically what we're going to compare is the difference between our other transformations, such as rotations, reflections, translations. Those things moved our figures. They changed location or even how they were oriented, but they never changed size. So what a dilation is it's a type of transformation, but it's not a rigid transformation because it can change the size of a figure. So let's go back and see if we can identify what kind of transformations are occurring here. So this one, we're circling which ones are rigid. So rigid ones are ones that change the location or the orientation, but not the size. So this one is not. This one, it's the same figure, it's just changed the way it's facing. So you can kind of imagine a line of reflection. It's been mirrored over that. So this is a reflection. Okay, this one is exactly the same shape. It is just in a different location. So this is also rigid. And this is just a slide, which remember our formal name for that is a translation. And then this one, it is the same shape and the same size. So it's also rigid, but it has turned kind of around this point. So this is a rotation. Okay, so those are rigid. Rigid cannot change size. Dilation is not a rigid transformation because it's the one kind that does change the size. However, it has to change it proportionally. So what that means is it doesn't stretch it in a certain way. It has to stay the same figure, just the size has changed. So notice this one is just kind of a blown up version of the other one, but its shape is still intact. So this is yes. The shape has been preserved. Okay. And this one is an example that would not be, because we would say that this is kind of like this part, right, is not proportional to this piece. So it's been stretched. We're going to call that unproportionally. Okay. All right. So this thing about expanding or shrinking figures, we call that a scale factor. And basically it's just a number that we multiply the side lengths of a figure by to change the size. And we have to multiply every side by the same scale factor if it's going to be a dilation, because it has to be that proportional change. So if our scale factor is a number larger than 1, it's going to make our shape bigger. It's an enlargement. If the scale factor is less than 1, for example, like a half, a third, then it's going to shrink our figure, okay, or a reduction. Now, how we find out what the scale factor is we just take the image length and divide by the pre-image length. Now, that's really important, though, that it's corresponding parts when we do that. So let's try that on this one. So here's my pre-image and my image. So we're going to use this formula. We're going to do image divided by pre-image. Now, the 6 corresponds to the 18. So I'm doing 6 divided by 18. I could also do 4 divided by 12. And if it's a dilation, these should actually be equal. So let's go ahead and reduce those fractions. So I can divide both those by 6 and get 1/3. I can divide both of those by 12 and get 1/3 as well. So my scale factor equals 1/3, and it's less than 1, so it should be a reduction, which it is. It started larger and it shrunk. Okay, here I'm given a polygon ABCD. It's been dilated by a scale factor of 5 to create my new image. What would the length of A prime B be if AB was 4? So all we have to do is take the pre-image 4, multiply by the scale factor, which is 5, to get the image. So A prime B prime, that same corresponding piece, now has a length of 20. Okay, so that scale factor is just using multiplication to change the size of our image. Give that a second to clear up here. There we go. Okay, so with a dilation, we have something called the center of dilation. So you can see here, C is my center of dilation, and Q is my pre-image, Q prime is my image, and notice they're all in a line. Same with P, P prime, and the center. If I draw a line through them, they all intersect at the same place. So that center of dilation is the point where those lines intersect, okay? So we have, on a grid, we have two different dilations we're gonna look at. So one is if it's centered at 0, 0. So if I'm using the origin as my center of dilation, it's really easy. We just take our scale factor and multiply by the coordinates. So that's what this second piece is saying here. So we're going to try that here. So they're saying what were the coordinates of A if A prime equals 3, 6, and our scale factor is 3 with the center of 0, 0. So we do pre-image times scale factor equals image, okay? So for us, we don't know the pre-image, so A times 3 had to equal this point, A prime, which was 3, 6. So essentially, what times 3 equals 3? What times 3 equals 6? So we're just working backwards, or we can think about dividing by 3 here. So that meant A would have to have the point, right? 3 times 1 gives me 3. And 2 times 3 gives me 6. So using that scale factor to work backwards is going to give us our point. And again, we can use that multiplication when it's centered at 0, 0. Okay, now we're going to look at one that's not centered at 0, 0. So this is what this last part is talking about. So the first thing I'm going to do is I'm going to plot the point. So they want me to use the center 4, negative 4. So here's 0, 0. So 4 and then negative 4 is my center of dilation. Okay, so that's my center. Okay, so we're going to dilate this by a scale factor of 1/2. So it's going to shrink, okay? And how I'm going to do this, because my center is not 0, 0, I can't just multiply the coordinates by 1/2. Instead, what we're going to do is we're going to look at the distances. So I'm going to go from my center to L. So to get from, and I'm kind of going to do it like slope, rise and run. So I have to go up 1 and over 1, 2, 3, 4. So instead of up 1 and over 4, I need to cut those in half, as that's what my scale factor is. So instead of up 1, I'm going to go up 1/2. Instead of over 4, I'm going to go over 1, 2. And that is where L prime is. Okay? Now I'm going to go ahead and do Z. So to get to Z, I have to go up 4 and over 8. So instead of up 4 over 8, we're going to go up 2 and over 4. So there is our Z prime. Okay, to get to J, we go up 2 and over 4, 9. So we're going to go up 1 and over 4 and 1/2. And there is J prime. So if we connect, we should be able to see the same shape. It's just a smaller version. And if I used a ruler, I could connect. Here, I'll show you guys that. I could connect the center through Z and Z prime, right? Those should all form a line. The center L through L prime and J through J prime. Sorry, those ones are really close. But they should all line up with our center. Okay? So that's kind of how we do it when our center is not 0, 0. We can't just multiply the coordinates, but we can look at the distances and multiply those by the scale factor. All right. Find the coordinates of the image of D if we have a scale factor of negative 1/3 with a center of dilation at the origin. Okay, so we are going to find D prime, E prime, and F prime. So I'm just going to rewrite these ones here, you guys. So because it's centered at the origin, all we have to do is multiply the coordinates by the scale factor. Now, multiplying by a fraction, such as 1/3, multiplying by 1/3 is the same as dividing by 3. Okay, so I'm going to multiply by negative 1/3. Okay, so that's going to give us our new coordinates. So negative 3 times negative 1/3 is going to be positive, and dividing by 3, that's really what I'm doing, is going to give me a positive 1. 3 divided by negative 3 is negative 1. Okay, we're going to do the same thing for the E and F prime coordinates. Okay, so E prime divided by negative 1/3, times negative 1/3 is negative 1. 6 times negative 1/3 is negative 2. So I'm just dividing these by 3, but because it's a negative, I am changing the sign. F prime times negative 1/3, negative 1. 0 times anything is still 0. So there are my new coordinates there. So the negative, all that does, you guys, is that is changing our signs, and we're actually going to see an effect of what that looks like on a graph here on our next example. Okay, so this one doesn't have to be super accurate, but I'm going to use a ruler just to help me a little bit. So we're going to sketch a dilation centered at P with a scale factor of 2. So again, my lengths are going to be twice the size, and I'm going to use the center to actually help. This is kind of like the graph where it's not centered at 0, 0. So my distance, I'm actually going to extend this. I know the dilations have to line up on the same line. That's got a nice crook. So I'm drawing a line from P through every vertex, and I'm just extending it like towards the edge of the page. And then P through that guy. Okay, so what I want to happen is I want a scale factor of 2. So that means the distance from here to here needs to double to get to my image. So I'm going to, here's 1, 2. So it's now twice as far away as it was before. Okay? From here to here, there's 1 distance, 2 distance. Okay? And then from here to here, same thing, there's 1, we're doubling it, so I'm going to put it out here. And then I'm going to connect. And notice I'm just using my fingers, kind of eyeballing. You can use a ruler too to kind of make it a little bit more accurate. And I'm going to, sorry, I got to move that point a little. There we go. Okay, connect here. And here. All right, so there's a sketch of a scale factor of 2. So again, I just used the distances and doubled it to get the new one. So if it's an enlargement, our scale factor is bigger than 1, it's going to get further away from the center of dilation. If it's a fraction, something less than 1, it's going to get closer to the center of dilation. So let's try one like that. This one is negative 1/2. So what the negative does is it has it go in the opposite direction. So I'm going to do the same thing. I'm going to connect P to each vertex, but I'm going to draw my line going the opposite way. Negative's going to go the opposite direction. So instead of continuing the line this way, I'm going backwards. Okay, same with this guy. We're going through P. And this guy. Okay, so 1/2, we are going to, again, kind of eyeball the distances here. So these distances need to be cut in half. So here's this distance. I want to cut it in half, okay? And then I want to move it the opposite direction. That's the negative part. So this point is now right here, okay? This guy, cut it in half and go backwards along that line. Okay, this guy, cut it in half, move backwards along this line. All right, so now let's connect those points and see what our new figure looks like. All right, so there is my, it's now half the size because these distances are half of what these ones were, but the negative caused it to go in the other direction, which also notice then it caused it to rotate as well. So that's the effect of having a negative scale factor. But notice because our scale factor was a half, it's closer to the center of dilation because it was a scale factor less than 1. All right, that's everything for the Intro to Dilations video. Thanks for watching.